All right, so let's take a look at a little bit of anti-differentiation. We've taken the derivative of functions, and let's see if we can go backwards here a little bit. There we go. So my first functions here, I have f prime equals 2, and I'm looking to find f of x. Well, to me, I'm going to ask myself, what do I take the derivative of to get to 2? Well, I know that that would be 2x. But the problem is I don't really know if it's 2x plus 0, 2x plus 1, 2x plus 72. So I'll write this as 2x plus a general constant c. And that's the convention that we'll use for all these antiderivatives as we work backwards, because the derivative of a constant is 0. And you can see in the next problem here where I have f prime of x equals 4x cubed plus 6. I need to work backwards. So what do I take the derivative of to get to 4x cubed plus 6? Well, really, if you think backwards, I really have x to the 4th because I'd multiply and subtract 1 plus 6x plus c. So you can see this sort of exponent rule here that exists in this first term is sort of this add 1 divide idea, where I'm moving from 4x cubed, I'm adding 1 and dividing, and that allows me to adding 1 to the exponent and dividing the front coefficient by my new exponent. That allows me to get to the power rule for antiderivatives. So let's move ahead one slide. I'm going to clear this out. All right. So sometimes it's not so straightforward. Sometimes we need to rewrite before we take the antiderivative. I know that as an exponent, this is really x to the 1/2 power. So if I go by my add 1 divide rule, I'm going to make this x to the 3/2, add 1, and divide, which is really multiplying by the reciprocal. So I have 2/3 x to the 3/2 power plus c. Now I can always check myself. If I take the derivative of f, do I end up with f prime? I'd multiply and subtract 1, and yeah, it seems to work out. My second problem, I have x 1 over x cubed, which is really x to the negative 3rd power. So I need to add 1 divide here. Now be careful, I have to add 1 to my exponent, which really makes the exponent negative 2, adding 1 to negative 3, and then dividing by negative 2 gives me a negative 1/2 out front plus c. And again, I can check my work. Is the derivative of negative 1/2 x to the negative 2nd really x to the negative 3rd? And yes, it works out. I can multiply and subtract 1, and that works beautifully. Okay, so let's move to the next page. We'll clear this off. Sometimes the rewrite's a little bit more serious, right? As you can see here, I don't really have a rule for this guy. What instead I'm going to do is I'm going to break this apart and make this 2 separate fractions. I'm going to make this x over the square root of x plus 1 over the square root of x. Just sort of undoing that fraction addition. I know that this is the same thing as x over x to the 1/2 power plus 1 over x to the 1/2 power, which is then the same thing as x to the 1/2 plus, running in the room, x to the negative 1/2. And that's probably a few more steps than I might show normally. Normally, I might just go right from this step over to this guy. But if you need all the steps, feel free to write them out. And at this point, I need to find the antiderivative. I need to add 1, divide. So I'm going to add 1 to my exponent, 3/2, and then divide, 2/3. Plus, add 1 to my exponent. I end up with 1/2, divide, multiply by the reciprocal times 2. And you can see how I did that. Oh, be careful, plus c. You can see I did that. I left some space up front for that coefficient. I added 1 first in my work and then divided. And go to the next slide. Clean this one off. So what about trig functions? Well, trig, you just have to sort of logically think through what the derivative would be to get to cosine x in this first case. Well, I know the derivative of sine x plus c would be cosine x. The derivative of sine is cosine, so I have sine x plus c. The next one, you think at first maybe I do some add 1 divide here with secant squared, but really the derivative of tangent x plus c would be secant squared x. I know that that rule was true from my early derivative chapter. So for a trig, you just sort of need to think through, what do I need to get to where I'm going? The derivative of what function is cosine? The derivative of what function is secant squared? And these, like most other things, will become more complicated as we continue to move down through chapter 4 as we investigate our intervals here. So in general, what does this look like? Well, if we have just some constant k, the antiderivative of that k would be k times x plus c, right? The derivative of k times x would just be k plus c. And in general, if I had a derivative that was x to the nth power, I would add 1, so x to the n plus 1, and divide, so 1 over n plus 1, and then, of course, plus c on the end. So you have two kind of general antiderivative rules, and really we would call this guy here the power rule, right? The power rule for antidifferentiation as we add 1 and divide. Add 1 to our exponent and then divide the front coefficient.